All right, so this is just more practice with trig proofs. Remember, you want to start on the more complicated side or the side that has an angle that's not just x. So for this one, let's start on the left side. And the first thing to do is get rid of the negative x angles by applying the even and odd identities. So cosine of negative x is equal to cosine of x. Secant of negative x is equal to secant of x. Tangent of negative x is equal to negative tangent x. And if I look at the right side, we're trying to just get 1 plus sine x. So we should rewrite these three trig functions to be in terms of sine and cosine. So I'm going to rewrite secant as 1 over cosine x. Tangent is sine x over cosine x. I can either common denominator and multiply by the reciprocal, or I could just say I want to get rid of this complex fraction. So I'm going to multiply by cosine x over cosine x. That wipes out the complex fraction right away. So the numerator is cosine times cosine, which is cosine squared x. The denominator is just 1 minus sine x because the cosines cancel out. Again, I'm trying to just get 1 plus sine x. So there's nothing you can do in the bottom, but the top, I can use the Pythagorean identity that says cosine squared is 1 minus sine squared x. And be careful on your algebra here. You can't go canceling individual terms at all, but you can factor this difference of squares in the top. 1 plus sine x, which is what we want, times 1 minus sine x divided by 1 minus sine x. So these 1 minus sine x's divide out to 1, and we're left with 1 plus sine x, which is what we wanted. All right, taking a look at number 2, even though the right side looks a little more complicated, I guess you could start factoring a little bit. You might get stuck on that pretty quickly. It's better to start, like I said, on the side that has an angle that's not just x. So 3x, negative x, x plus pi over 6, 2x. We're going to be starting on those sides. So how do you work with a 3x? Split it up into a sum of 2x plus x. This allows you to use the sum formula for cosine. So that's cosine 2x times cosine x minus sine 2x times sine x. And then this allows us to use some double angle formulas. Remember, there are 3 options for the double angle formula for cosine 2x. The original is cosine squared minus sine squared. You can always use that and then replace what you don't want. But you can make things, 1 or 2 steps shorter in your trig proof. If you take a look at the right side, this only has cosines here. So I want to use the cosine 2x that only has cosines. So that's 2 cosine squared x minus 1. And it needs to be in parentheses because it's being multiplied by this cosine x here. So again, if you did cosine squared minus sine squared, that's fine, but you're going to have to replace the minus sine squared with a 1 minus cosine squared, which would get you here. There's only one option for sine of 2x, and I want to put this sine here out in front so I don't forget about it. Sine 2x is 2 sine x cosine x. So this does not have 3 options. It's always just this formula. The next thing we should do is get rid of parentheses by multiplying. So distribute the cosine through. 2 cosine to the third x. That's a good sign because we're supposed to have that. Minus cosine x. You're not distributing this through. You're just multiplying this term times this term. So just make the signs sine squared. So minus 2 sine squared x cosine x. It's not like 2 sine squared x cosine sine x or anything like that. There's no addition or subtraction happening in that parentheses. And then again, I want to get rid of the sine squared because this only has cosines in it. So I'm going to use the Pythagorean identity on that. Just copy down these terms first. This minus 2 and cosine are going to get distributed through, so I'm going to write them together. And then sine squared is 1 minus cosine squared x. And again, we have to distribute. We should be almost there. So when I distribute, I get minus 2 cosine x plus 2 cosine to the third x. And the last step should just be combine like terms. So 2 plus 2 is 4, cosine to the third x. Negative 1 minus 2 is minus 3, cosine x. And that's what we wanted. Take a look at number 3. Again, I want to start on the side that doesn't have just x for the angle. So I want to start here. And if I see addition in the angle, then I should use my sum formula, this time for sine. So expanding that out, it's the sine of the first angle times the cosine of the second angle. So that's sine of x times cosine of pi over 6 plus cosine of the first angle times sine of the second angle. And then this one should be pretty short. The next step will be to evaluate sine and cosine of pi over 6. So sine x, think about the unit circle. The x coordinate at pi over 6 is radical 3 over 2. And again, the unit circle, the y coordinate at pi over 6 is 1/2. Take a look at what you're supposed to get on the right side. They basically have this. They just have factored the 1/2 out. So that's all we have to show. Take a 1/2 out. And yeah, you'd have a radical 3 in front of your sine x and just a 1, so just plus cosine x. One coefficient in front of your cosine x. So that proof is finished. Take a look at number 4. Again, I want to start on the side that has an angle that's different than just x. So let's start on the right side this time. And again, we have 3 options for cosine of 2x. If you want to do this in the fastest way possible, the least amount of steps, take a look at the other side. It's only in terms of sine squared. So when I replace cosine of 2x with something, instead of cosine squared minus sine squared, and then having to do a substitution on the cosine squared, I can just make it 1 minus 2 sine squared. If you have that memorized, you're saving yourself the substitution step. If you don't have it memorized, it's okay. It's one extra step. It's not a big deal. But you will need to make that substitution to get rid of any cosine squareds you have and keep everything in terms of sine squared. So then we distribute that. 1 minus 1 plus 2 sine squared all over 2. So those ones are going to cancel out to 0. 2 over 2 is going to reduce. So I think I can just say sine squared x. All right. Now, my original worksheet had something that I think we need some identities that we haven't learned to easily get to this place. So I'm changing this problem. So it's cotangent of 2x equals 1 plus cosine 4x over sine 4x. So this equation has 2 sides that have weird angles. So I'm going to default to the side that has larger angles to work on. So I'm going to work on the right side. I might remind myself, okay, cotangent of 2x, if I can get this side to be cosine of 2x over sine of 2x, that is the cotangent of 2x, because we did not learn a double angle identity for cotangent. So this is your goal. So let's see if we can get there. Now, our identity sheets are in terms of cosine of 2x and sine of 2x. So what do we do if it's a higher number? So the formula is really, for cosine of 2x, it's really like cosine squared of half the angle. So if this is the angle and it becomes cosine squared x minus sine squared x, if this 2x is 50x, these angles would be 25x. You cut it in half. That's the pattern. So here, if it's cosine of 4x, and because I want cosine of 2x over sine 2x, I think I should use the cosine only version. So I'm going to say use my double angle, but it'll be 2 cosine squared 2x minus 1. Over sine of 4x does not have options, but it does 3 options, but it does have the same rule. So if this is a 4x, it's still just a 2 out in front, but it's sine of 2x cosine of 2x. Okay, so picking the cosine only version was helpful because the ones will cancel out. And then if you just have 2 cosine squared of 2x over 2 sine of 2x cosine of 2x, Because there are no separate terms, this is a single term over a single term, you can cancel a lot more. The 2's cancel. This cosine 2x cancels with this one. So you are left with cosine 2x over sine 2x. And I'm pretty sure we had this in one of our homework problems. So this might be familiar. And then remember, we're not stopping there. We can't get the left and the right to match, but we just have to take this one more step to say quotient identity, cosine over sine is cotangent of that same angle. Cotangent of 2x. Okay, last problem, I think. Yeah, there's no back to this worksheet. Even though tangent can be easy to rewrite, I think it's better to start on the side with the weird angles again. So this looks like we're just going to use a sum and a difference formula for sine. So let's expand that out first and see where that takes us. So sine x cosine y plus cosine x sine y. And the bottom should be the same thing, just with a minus sign in the middle. Sine x cosine y minus cosine x sine y. And I want you to be careful here. You can't cancel anything because these are separate terms separated by addition and subtraction. So you can't go canceling individual terms. What are you supposed to do? This needs kind of a sneaky trick here, but take a look at the right side. Go ahead and look at it. If you were to begin on the right side, it would have been, all right, tangent is sine x over cosine x. And tangent y is sine y over cosine y. And similarly for, my pen just stopped working. Similarly for the bottom, right? So do we kind of have pieces of that? Yeah, we have a sine x and we have a sine y. I would like to get rid of the cosine y and get rid of the cosine x. And so what if we say we're going to divide by cosine y times cosine x? If you do that, you have to do it on the top and the bottom. And what would that look like? So sine x cosine y divided by cosine y. Let me write it down here. If this is hard to see, let me just show this. So all I'm saying is divide this by cosine y, cosine x. And you have to do the same thing for every term. Now, whether or not you show me this step, you need to write it down over here. But whether or not you show me this step is kind of up to you. But I'm just helping you visualize it. If you're watching this video, you might be doing it because this was confusing just looking at the answer key. Oops. Try to write it down correctly. I'm writing all the blue stuff first. Okay, so what I did was divide everything by cosine y, cosine x. Every single term gets divided by that. Now here, some things should cancel within each fraction. So let's take a look. So in the first fraction, the cosine y's cancel. In the second fraction, the cosine x's cancel. So what are we left with up there? We're left with sine x over cosine x. That's good because we want tangent x. Okay, and then plus the other fraction, you're left with sine y over cosine y. Similar things will happen in the denominator. You're going to get the cosine y's to cancel. Sine x over cosine x minus, oops, I canceled the wrong thing. The cosine x's cancel in that one, so sine y over cosine y. And those are all quotient identities for tangent. So tangent x plus tangent y over tangent x minus tangent y. All right, if you started on the right side, you would have had to basically work backwards like this. You would have said, gee, I want to get rid of these cosines, so I would have multiplied both sides by cosine x, cosine y, and maybe that would have been easier. I don't know. And then you need to recognize that the result you have would be a sum and difference formula. So you probably could take these exact steps in reverse, but right here it would say times cosine y, cosine x, instead of back here where I divided it. All right. Hopefully this gave you a bit more practice on sum and difference and some double angle. I think double angles tend to be the most confusing because you have so many options. So we will keep reviewing and practicing. And please come into office hours before the day of the test if you have questions.